Morning, everyone. Welcome to a new week. May the 4th be with you, I guess, is the day today. Just want to remind you, test is Wednesday from 10 to 11:30. It's the only time to take it. Unless I hear something today by midnight tonight that you can't do it at that point in time, that's the only time. There's no makeups if you miss it. It is what it is. You're responsible for this. Be proactive and not reactive with things. Zoom review. I've gotten exactly one person respond that they want the Zoom review tomorrow. It's completely up to you. My guess is like 10 o'clock. We'll kind of keep it in that wiggle room for you guys. It's a little better for you. I like it earlier, but we'll move it back a little bit. But unless I get some more emails, I don't know. If it's just a one person, I'll have to do something else. All right. What I highly recommend is I have not assigned a lot of the pages in the packet. I'm going to throw a lot of the answers at you today in the classroom thing. You need to do those. You need to do the practice questions. You need to and check your answers because that will be very helpful for the test. There's not, in this distance learning format, there's not a lot of question answer feedback. And you don't have a lot of practice unless you do it. So I would also highly recommend your review books. Regents kids, I'm going to give you the answers for the unit today. Honors kids, you guys have your review book answers or the answers for the review book right there. Okay, today we're going to talk about one concept called entropy, which is different than enthalpy. We talked about enthalpy before, which is heat of reaction. Don't forget, your test, your test is Wednesday and your lab write-up is due Friday. You just did the rates of reaction lab. The data for most people was really, really good. So that's good. Graphs, you guys still need some work on graphs for some people. You're giving multiple lines on graphs. Realistically speaking, you only need your data points. You're not clicking on the right graph is what it is. And other people are giving me bar charts. We never have bar charts in chemistry. So make sure that you adjust those. You're going to be making graphs for this Friday's lab as well. So just so you know about that. All right, here we go. Bell ringer. And like normally, just stop, pause the video, and think about it. And then, because I'm going to go kind of quickly through it so the video time doesn't take up. All right, so here it says in terms of Le Chatelier's, remember Le Chatelier is a response to a stress. What could you do to increase the production of hydrogen fluoride? This thing right here is hydrogen fluoride. All right, so what could you do? All right, you could add hydrogen. If you add hydrogen, it's going to shift it to the right, which means it's going to make more hydrogen fluoride. If you add fluorine, you're going to shift it to the right, which is going to make more hydrogen fluoride. If you take away heat over here, or you decrease the heat, it will shift it to the right. And then the other thing, which we don't really talk about a lot, but if you want to make more hydrogen fluoride, remove the hydrogen fluoride that is made. All right, that decreases the amount of hydrogen fluoride, which will also shift it to the right as well. So all of those things will cause an increase in hydrogen fluoride or a shift to the right. Remember, answers for Le Chatelier's are shift left, shift right, or no change at all. All right, so to make more hydrogen fluoride, you can increase hydrogen, you can increase fluorine, you can decrease the HF, you can decrease the heat. All right, or remove the HF, that's decreasing it. Okay? All right, so common ion effect. This is a great demo in class. I don't have the materials for the demo, so I can't really do it, but I'm just gonna talk about it real quickly. Two different ionic compounds that have an ionic compound. So right here, so you got NaCl and HCl. All right, so right here, what happens is NaCl, if we add HCl to a system that's got like dissolved and undissolved sodium chloride, what happens is the common ion is chlorine in both of them. So what you can do is you can actually shift equilibrium for the chlorine by adding HCl to it. So if you look at this reaction right here, you got sodium chloride, and this should have a little S right here for solid. All right, and you got dissolved sodium and dissolved chloride. So you got aqueous sodium and aqueous chloride. If I were to add HCl to this, all right, HCl is not directly related to any of these, all right? But we know that HCl, or you should know that HCl will separate out into hydrogen ions and chloride ions. So if we add HCl to this, what we're actually doing is we're actually adding chloride ions. And what that's going to do is that's going to shift equilibrium to the left, which means you're going to make more solid salt. So you'll actually pull you'll actually create salt in that situation. You'll have a clear liquid, and you add the HCl, which would then make salt. You would also add some hydrogen ions in there, which changes the pH. All right, remembering from acids and base stuff. All right, but we're only concerned about the salt, so you're actually going to make salt. All right, which is kind of cool. It's kind of cool to see you add HCl and it makes the salt. I can't bring HCl home, or I can't get that strong strength HCl out of the building, so I can't do that here. And it doesn't work with weaker concentrations of it. All right, so that's a common ion effect. Just look at the things, if it doesn't look like they're the same thing, which NaCl and HCl are not the same thing, but look for that common ion, that ion that's the same. So here, chlorine and chlorine. All right, so that's going to shift equilibrium back to the left in that case. All right, when do physical changes occur? All right, entropy. We don't have to know the variable delta S. If you go on in chemistry, you'll have to do some math with this. All right, entropy is disorder. All right, it is disorder. Oh, hopefully my phone makes it. Just went into low power mode. It's disorder in a system, all right, or messiness, all right? So think about, in your world that you live in, all right, which is right now probably a lot of it's your house and your room, all right? Does the disorder or messiness of that room increase or decrease on its own? All right, and this is normally where we have a big discussion in class, but it's hard to get feedback from you guys. So generally speaking, disorder increases on its own. So think about you. All right, you go into your room, you're going to bed, you throw your clothes on the floor, you get into bed or put your pajamas on and get into bed, you get up, you get out of bed, you leave your bed the way it is, throw your pajamas on the floor, put clothes on, all right? So entropy is constantly increasing. All right, it takes energy on your part or effort on your part to keep your room clean. Think about if you were to walk in the woods, all right, are all the leaves and sticks all picked up nice and neatly, tidy, and everywhere? No, they go wherever. All right, so things in nature tend to proceed towards disorder or increase in entropy. All right, so that's the order of progression of things. And then we're going to learn later today that energy, things are going to go to lower energy versus higher energy. All right, the more order you have, the less entropy. So high order, low entropy, low order, high entropy. All right, we'll go through some examples, and this is saying the same thing. The less order you have, the more entropy in your system. All right, so we look here. So which one of these things, solid, liquid, or gas, which one has more entropy or is more entropic, if you want to use a technical term? All right, this one's pretty ordered, kind of ordered, not ordered at all. So the most entropic system is gas. And that's good to know, because this is kind of leads you into the questions that you're going to see for this. They're going to ask, which of the following has the most entropy? And by and large, more often than not, entropy questions deal with phases of matter. Now, the other thing that could be interesting or be highly entropic is aqueous. All right, AQ, dissolved in water. All right, so gas and aqueous, we wouldn't be able to tell the difference between, more entropy or less entropy, but you can refer it to solids and liquids or compare it to solids and liquids. All right, a phase change is the most significant factor in delta S, which is entropy. All right. All right, so solid to liquid to gas. I'm going to go through this quickly, or aqueous to gas. All right, and this is just kind of going through this progression. Entropy increases when a compound is broken down. So if you take a compound and you break it down into its component elements, that's an increase in entropy. All right. And the opposite of that, entropy decreases when a compound is created. So you're taking two things, making one thing. That's technically less entropy. All right. I know I'm talking fast on this, just trying to make the videos as quick as possible. You can always pause it. The Ed Puzzle will pause it too, because I will ask questions at these points in time. All right. Natural law, the course of reaction. Reactions tend to form more stable products. All right. So they're going to be releasing energy or exothermic. So exothermic reactions produce more stable products. So it's a negative delta H is an increase in stability, and then increase in entropy. All right, increase entropy increases stability. So that's the kind of a double whammy question that they'll ask you. Which one of the following produces more stable products? The exothermic reaction and the one that's increasing entropy. All right, so those are the two characteristics or factors that would make things happen or produce more stable projects. TGT, this is a page in your a review kind of test quiz game that we would play. I'm just going to give you the answers for it. It's a bunch of multiple choice questions. I forget what page numbers they are when I put it on the classroom today, you'll definitely have the page numbers there. All right, I can't say enough to make sure you do practice problems before the test on Wednesday. Periodic review is already up. 3/4 of the periodic review is kinetics and equilibrium, so it's probably a good place to start your review. All right, because you get instant feedback if it's right or wrong. All right, and once again, if you want to participate in the Zoom or would be interested in Zoom, if you have questions on things, shoot me an email. All right, okay, we'll talk to you or see you. Actually, I won't talk to you again until probably Friday, because Wednesday we won't have an official video lesson because you'll have the test at 10 o'clock. All right, have a good day.